Let's now tackle the second problem of recursion on arrays. And specifically, we want to determine if an array of integers are sorted in a non-descending order. Okay, let's now see exactly what that means, by using some example. What about empty array? Well, basically in the empty array, can you find any counterexample to show that it is not sorted? You cannot. So that means it must be sorted. Similar to, are all the numbers in the empty array positive? Yes, because you cannot find any zero or non-positive. Well, you cannot find any zero or negative value in the array that prove that it is not positive. So that means it must be positive. Similar reasoning pattern over here. What about this one? As long as you go from 1 to 2, it's rising. 2 to 2 is not, as long as it's not decreasing, then you're okay. So 1 to 2 is not decreasing. 2 to 2 is stay flat. It's not really decreasing. 2 to 3 is okay. And 3 to 4, that's also fine, right? As long as the element there, every two adjacent elements are less than or equal to. For example, 1 is less than or equal to 2. 2 is less than or equal to 2. And 2 is less than or equal to 3. And also 3 is less than or equal to 4. In that case, you'll be true. What about this case over here? Can you find any counterexample where it is not the case that A at index I is not less than or equal to A at index I plus 1? Can you find any counterexample? Yes, indeed. Look at this. Is it the case that 2 is less than or equal to 1? It is not. So this is exactly the witness of the property being violated. So that's why it should be false. Alright, so that's the problem we want to solve recursively. Again, it would be quite trivial for you to solve this problem using a loop, iteratively. But that's not the point. We want to really solve it recursively. And the solution will be incredibly similar to how you actually solve the earlier problem about if all the numbers are positive. The only thing is about the basic operation you want to perform to really combine the result with the result of recursive call. That's the only part that's going to be slightly different, but the pattern overall is going to be very similar. So I'll do a little bit quicker for this example to save time. All right, you can pause the video now, or if you want to hear more hints, you can do so. All right, let's now give you a little bit more hints. What about base case? Well, the same as before, it's going to be empty array. For the empty array, you're just going to return true because you cannot find any violating adjacent pairs that's not sorted. That's not actually sorted in a non-descending order, right? That's kind of the argument, as I said before. And this part has been said. You can just read it again. What about if the array is not empty? In that case, it's going to be a recursive case. We cannot get a solution immediately. In that case, what you're going to do is you're going to look at the first and second elements and make sure the first is less than or equal to the second elements, right? For example, you're going to make sure 1 is less than or equal to 2. And then you want to make sure not only this, but also for the rest of the array over here is also sorted appropriately, right? So that will be the idea. So you can think about this is what you're going to do for the first and second elements, and then you want to make sure starting from the second elements until the end, the tail of the array is also sorted in a non-descending order. So that'll be the idea. All right. So that'll be the idea, and then you can see the tail of the array in this case will definitely be a strictly smaller problem. Let's talk about just these two examples. You can see 1 is less than or equal to 2. And also in this case, 1 is less than or equal to 2. However, in this strictly smaller problem, are the elements sorted? Indeed, 2 less than or equal to 2, 2 less than or equal to 3, 3 less than or equal to 4. So that's good. On the other hand, is this strictly smaller problem sorted? No, because you can still find this violation pair. So that's why this result will be false. Okay, let's now go over the Java code. Actually, before I do that, I should let you pause the video and think about how you program this in Java. All right, pause the video if you wish. All right, assuming that you thought about it and sketch your solution maybe, and also even better if you're implementing Eclipse. But let's now take a look at the example, the solution. Okay, very similar pattern as we said before. First of all, I want to highlight again, this is the method we want to define taking a single parameter of an array, and this part over here is a call to a recursive helper method. Okay, so this is really the so-called recursive helper method. Okay, recursive helper method. Right? And let's now visualize what's happening over here. So if you got input array A, okay, so A is pointing to the beginning of some array, okay, with different elements. Let's say 0, and also 1, and also the rest of the array, right? The last element will be A.length minus 1. Okay, let's now take a look. So we really intend to really go over from 0 until inclusively A.length minus 1. So we want to scan through the entire array to determine if all the elements are sorted. Okay, so the from will be 0 over here, and also 2 will be A.length minus 1, right? So that's the from, and that's the 2, right? The 2 indices. And we got 2 base cases over here. Let's again annotate. So these 2 branches are the base cases. And this part over here will be the recursive case. So this part here is the recursive case. And let's look at it more closely. Recursive case. Okay, so what we have is A at index from and less than or equal to A at index from plus 1. In the beginning, we're going to get the from and also from is going to be 0 in the beginning, right? To start with, that'll be the first call. So we are talking about A at index from. So you can think about this part over here. We want to make sure they actually satisfy the less than or equal to relation. So this element must be less than or equal to this element over here, right? So this that will be this part that we are comparing, right? This part here. What about the recursive call? This part here is the recursive helper method call. Okay, and this one here we actually got from plus 1. We are still using the same reference A, call by value, from plus 1 and then 2. So this is what we are doing here. So we want to make sure this part here, the purple, all the way to the end, right? You can see we go from plus 1 and then until 2, which will be the last element in the array. Let me move this a little bit to here. Okay, I think that'll be better. Okay, so this is the recursive, strictly smaller problem. So that's a strictly smaller problem. And we are calling this, we want to make sure this part here is also sorted. Okay, so in order to claim that the entire array is actually sorted, we need two conditions. Number one, we want to make sure the first 2 elements are sorted, meaning that less than or equal to. And then we want to make sure, starting from the second element over here, the entire subarray that's strictly smaller is also sorted, which is exactly what this recursive call is actually doing. Right? So that's kind of the logic behind the code. Let's now try to trace some cases. Okay. Let's look at 2 base cases as before. Okay. Let's say A is simply just empty, right? So if A is simply just empty array, so that means we got empty array over here, and we got 0 and always A.length minus 1. A.length will be 0, 0 minus 1 will be minus 1, right? So that means we got 0 and then minus 1. And that one is going to satisfy this base case. So 0 larger than minus 1 is actually true. So that means we're going to return true. Right? So the execution path is going to be calling this recursive helper method, and then we satisfy this first case branching condition, and then we simply return true. That's what's going to happen. Okay, 0 minus 1. This one is rather straightforward, just like the is all positive method that we did earlier. Okay, you just want to make sure you return the right value for the base case. Okay, what about the second one? The second base case is like this, in a similar way. So we now got this array of single elements. So A is going to be a single elements array over here. So A.length minus 1 is going to be 0 because the length is actually 1. And then we're going to call this recursive helper method. And then we're going to say 0, strictly larger than 0 is going to be false. So we don't really execute a branch. 0 equals 0 is going to be true. So we execute a branch, right? It's going to return true, right? Exactly over here. So the execution path is going to be calling the recursive helper method, and then we don't really execute the first branch for the base case, but we execute the second one, and that's going to return true. And so far we haven't gone to the recursive case just yet. Okay, let's now look at the recursive case, case number 1. Okay, let's say the array that we want to look at will be A is pointing to an array of size 4. And we got 3, 6, 6, 7, 0, 1, 2, and also 3. Okay, let's now put the element there. So that'll be 3, 6, 6, 7. Okay, the tracing of this method here will be very similar to what I did in the earlier video, which is over here. Okay, so I'm not going to do as detailed as in this is all positive method, because I've done that already. So I would suggest I do in a very high level way, just to show you how things will work similar as before. I'll highlight the differences though, and then you should really do as an exercise the complete tracing for yourself for the next example. All right, for the next test case. Let's now start with this. So if I start with is sorted A, okay, over here. So that means A is going to be replaced by 3, 6, 6, 7. In turn, it is going to execute the recursive helper method from 0 to 3, right? From 0 to 3, that means from 0 to A the length minus 1, which will be just 3, because the length is actually 4. Okay, so far so good. So the intention is to really go over the entire range of indices in the array. And let's see how many recursive calls that we're going to do. We're going to do 1, 2, and 3. 3 recursive calls in total, right? And for every recursive call, for every call to the recursive helper method, we actually have to compare the adjacent elements from and from plus 1. You can see here, that'll be from and also from plus 1, right? Remember, that's the indices, right? Let me just highlight that one specifically. So that'll be from and then from plus 1. Okay, so that'll be from and from plus 1, from and from plus 1, from and from plus 1. And more specifically, let's take a look. For this particular call to the recursive helper method, from is actually 0. That's why you see 0 and 0 plus 1. In this recursive call, from will be 1. So 1 and 1 plus 1. In this recursive call, from is 2. So 2 and 2 plus 1. Right? I'm just trying to present the tracing in a slightly different way. You should definitely still try to see how this particular tracing structure has been constructed. That's something I will need to rely on you. Let's go a little bit further. And for this particular recursive call, let's say this. When I go from 1 to 3, right, it's because when I'm here, right, when I go to this recursive call here, I need to go from plus 1. Over here, from plus 1. So that's why you will see 0 plus 1 becomes 1. 1 plus 1 becomes 2. Over here, 2 plus 2, it will become 3, right? So in this case, 1 to 3, so that means we are looking at this strictly smaller subproblem to see if that one there, if all the elements in the subarray are sorted, right? And the next one, let's say we got, let me use maybe pink, okay? And we got 2 to 3. So that means we are looking at this particular part of the subarray, right? And also finally, we are actually looking at, as purple, 3 to 3. 3 to 3 is really this element over here, and which will be the base case. In the base case, what's going to happen is we're going to execute this base case over here, right? When from is equal to 2. In that case, we just return true, right? So this part here is just going to be replaced by true. And then you can see all these comparison over here, 0 less than or equal to 1, 0 less than or equal to 1, 3 less than or equal to 6. So that one's good. And also 1, index 1, index 2, index 1, index 2, index 2, index 3, index 2, index 3, right? That's what the comparison is going to be for each level of the recursive call, right? So things will still work nicely, and eventually it's going to return true, because this will evaluate to true, and also this will also evaluate to true. True and true, right? We are using just conjunction over here. That will be conjunction There will be conjunction as well. So true and true is going to be resolved for this recursive call. So it's going to be true. And then this will also be true. True and true is also going to be true. True. And this part over here is also going to be true because 3 is less than or equal to 6, right? For example, this will also be true. So true and true is also going to be true. And that means this is going to be true eventually, right? I try to be a little bit fast over here, but you should really know that it's very similar to how we trace the is all positive method as before. All right, as an exercise for you, you should really try to trace to see why this particular input array is actually not sorted. And for this one here, what we expect to see is it's going to return false eventually, but you want to see why. Okay, so this will be an exercise for you to do tracing. Okay, so that'll be an exercise for you. All right, so that's about what I want to discuss about this last example for recursions on arrays. Let's now go back to the slide to see what's left. Okay. All right, so that's the code we just spoke about, right, for is sorted, and that's it. Okay, and that will be the end of this lecture about recursion. It's only some gentle introduction to recursion. I think we really try to give you all the basic ingredients of how to program with recursion. We started with how to solve a problem recursively in general, and we gave you the principles. We talk about Fibonacci sequence and also factorial to show you how the cost that will work, and also show you what's the higher level of tracing recursive methods. And then we talk about recursions on strings and also recursions on the array. Specifically, we show you the more efficient way of call by value just by passing the reference of the array. And then we just keep reducing the range of the indices that we want to focus on for the inspection for the implementation. Right, that's basically what we have done in this module here. And beyond this lecture here, I will suggest some exercises. And I will give you a earlier lab exercise from fall 2019. So that lab over there actually was assigned to students to do a series of problems that should be solved recursively, especially all of the inputs and outputs. They actually involves either array or maybe array list. So that's something I will give to you as an exercise. So you should really do it to really complement your understanding for what you have just learned from the two examples. And there will be a note that I want you to read as well. So this note is really just about a summary of how the solution pattern has been instantiated in every one of the problems that we have discussed so far in the lecture. And you can look at the API for the strings for other methods on the string if you wish. And then, as I mentioned in the very beginning of the module, we got these two links from coding bats. So these are extra exercises for recursion. I would say definitely try to complete this earlier lab exercise first, and then try to do something extra here. If you can complete all of them before the exam, I'm pretty sure that will help. And finally, beyond this course, if you really want to master the skills for recursion, you may just want to learn yourself some purely functional programming language. My recommendation would be just Haskell. All right, that's about it, and that's the end of the course. And thank you so much for your patience. And then that's it. That's about everything I want to speak about for the course. And we have learned quite a lot. And good luck to your exam. Take care.